Thank you, sir. All right. So before we can start graphing absolute value functions, we need to remember what absolute value functions are. And so the absolute value function is where it's written in like straight up and down, kind of like you took a parentheses and like flattened it. That's what an absolute value looks like. And the way we word it is the absolute value of x is the non-negative value of x. That says value, not valve. Non-negative value of x. The way that it works well for me to think about it is like a Fitbit or my Apple Watch or whatever. We are without regard of sign. Or how many steps from 0. Because my Apple Watch here does not care if I take 3 steps this way or if I take 3 steps this way. Still counts as 3 steps. Doesn't matter if I'm going to +3 or -3. I took 3 steps. So absolute value is how Apple Watches count steps. And we are going to practice graphing these, making tables for these. And we're going to do it a couple of ways. And try to make that a little overzealous and easier. So, I need 3 graphs, but I only have batch up 2 good batches. So I have 2 new ones. This is your market then?
No, it's only one in here.
I was gonna say, you might have to here.
Okay.
I feel like we fixed it, like disappearing, so please make sure we get that back on. Because what we're going to start with is we are going to start with graphing y equals absolute value of x. Just so we can see what this looks like. It might have been a minute since we've seen it. So we're graphing our very first graph. This is called the parent function because it is the basicest of basicests. There's nothing else attached to it, just absolute value of x. And what we're going to do is very much like how we did some of our pieces yesterday, where we pick x's to find y's. Since this is not a y equals mx plus b kind of guy, we need to have at least 5 points. We want to make sure we get on both sides of our axis. So I recommend we stick kind of in this zone here, -2, -1, 0, 1, and 2. You can absolutely do more. If it helps you see better, keep plotting. Plot more points. But as we're working with graphs more and more, we're going to use this set for every parent function and as the basis for a lot of our graphs throughout the year. -2 to 2. Because what that gives me is a really good view of the middle of our graph. So then what we're going to do is we're going to take that x and substitute it into our equation. Into the absolute value. So the absolute value of -2 is +2. Because -2 is 2 steps away from 0. It's how many steps away. So what is the absolute value of -1? +1. The absolute value of 0 is 0. It's 0 steps away from 0. Absolute value of 1? 1. And absolute value of 2 is 2. Okay, so this gives us our ordered pairs to plot. -2, 2.
It can be non-linear, correct?
Correct, because it's about to go kaboop, kaboop. If it helps, you can keep graphing and thinking about it. So the absolute value of 3 is 3. The absolute value of 4 is 4. The absolute value of 5 is 5. The absolute value of -3 is 3. The absolute value of -4 is 4. So you don't always even have to write them down to plot more points. And we can start to see what this is looking like. This is shaped like a letter V. So this is kind of the basic shape we're going to have. Everything else for absolute values is going to be based around this shape. They're all going to be kind of V-shaped. Questions on how we got any of those pieces? Okay. Let's do our domain and range real quick before we go on to the next thing. What is the domain? All real numbers are -infinity to +infinity. What is our range? All positive numbers. So we can word that as y has to be greater than or equal to 0. Or you could do the 0 to infinity. Either way of wording that means all positive numbers. Or all non-negative numbers. The reason they have this right after those funky piecewise functions that we did yesterday is these are doable as a piecewise function. If I put a wall right there, I've got a line to the left and a line to the right. They're just a very specific kind of piecewise function that we have other things to do with. Okay? So what we're going to do next is we are going to play around with some of these, but all we're doing is putting in values in the table. I will show you a shortcut way to do it on Friday, but today we're just going to plug stuff in. When we're graphing and it's got other numbers and things around, you got to make sure when we're plotting points that we get points on both sides of the dip and the V. We always got to find the bottom. But what we're going to do is we're going to pick x's. I'm going to give myself a little space this time so we have space to write stuff down. And then I'm going to do y. I'm just using that middle space as workspace. It's not super duper fancy. I got it, dear. Thank you, dear. All right, so we're just picking x values to find y's. We can always start with that middle 5. Our middle 5 being -2, -1, 0, 1, and 2. then what we're going to do is we're going to evaluate our absolute value. So we're using our expression 2 times the absolute value of negative 2 minus 1. I'm going to give myself a little bit more space here because I want more space. There we go. Because what is the absolute value of negative 2? 2. So that's 2 times 2. What's 2 times 2? 4. Minus 1. 3. So our y value is 3. If you need to have space to write, you can do it like this. I know it's not the most easy thing to read up there. We're just substituting values in. So we're going to have 2 times the absolute value of negative 1 minus 1, which is really 2 times absolute value of negative 1 is positive 1. 2 times 1 is 2 minus 3. Oh, sorry, I wrote that down wrong. That's supposed to be minus 1. I was going to say that felt like a big jump. So 2 times 1 is 2, minus 1 is 1. That is one of the reasons it helps to write things down and look at them. It was much easier to figure out that I went wrong when I was that close to all my work. I got it. I'm going to have 2 times the absolute value of 0 minus 1. Absolute value of 0 is, how many steps away from 0 is 0? 0. 2 times 0 is 0. So we have 0 minus 1, which is negative 1. Two times the absolute value of 1. And you can do these like in your calculator or on scratch paper. I don't care how you word it. You do not have to fill in the middle like this. This is just a space and a tool to kind of keep our thoughts organized. And if you hate it, do it a different way. Your paper, your choice. Absolute value of 1 is 1. So 2 times 1 is 2 minus 1. 1. And then our last one, we've got 2 times the absolute value of 2 minus 1. So 4 minus 1, which is 3. And that gives us our points to plot. We have my x over here, I have my y over here. So if you ever need space to work, you can kind of just smush out the middle of your table and make it do a thing. 1, 0, negative 1, 1, 1, and 2, 3. And we can see there that I have definitely found the bottom of the V. So I have found the center. I cannot stop until I have figured out where that dip is in my V. So I always start with those 5 middle points. And if we don't happen across the V, then we can scooch outwards. So let's talk our domain on here. What's the domain? for this function? All real numbers. It goes from all the way to the left to all the way to the right. All real. And our range? Yeah, y is greater than or equal to -1. So we're all positives, you're right, but it does go a little bit lower than that. So we got to make sure to include the little tip of our v. So y is greater than -1. And we're just doing one more like this. Okay? One more kind of funky absolute value, and it's a long one. 1/2 times the absolute value of x minus 3 plus 1. And we're going to pick x's to find y's. And we can kind of see if we're going to hope that our middle values are going to work. And we're going to evaluate those. 1/2 times the absolute value of -2 minus 3. We do what's inside the operation first. So -2 minus 3 is -5 plus 1. So the absolute value of -5 is +5. +5 times 1/2 is going to be 2.5 plus 1 gives us 3.5. Yes, dear. I did the inside my absolute value, my x minus 3, -2 minus 3. Okay. So we treat it like parentheses and do what's inside it first. So now we're going to do -1. In the same spot, inside my absolute value. So we do the inside first, and we have our 1/2 times the absolute value, -1 minus 3. -4. Plus 1. The absolute value of -4 is 4. So we get 1/2 times 4, which is 2, plus 1, 3. It's a lot of work to get a 3. If you need to do it off to the side, this one's definitely our longest one of the day. Substituting it in 1/2 absolute value of 0 minus 3, which is -3, plus 1. Absolute value of -3 is 3. 1/2 times 3 gives me 3/2 or 1.5. Plus 1, which gives me 2.5. This one feels so long. We're going to keep on trucking. 1/2 times the absolute value of, into our absolute value section, into our 1 minus 3. It's going to give us -2 plus 1. So we have 1 goes in right here. 1 minus 3. So finish that one out. Pieszki. I believe it is 14, but let me grab my paper real quick and check. Uh, 13. Yes. Mm. All right, so what do we get for our y for that one? Can we get all the way to the end over here? Yeah, it's going to be 2. Absolute value of negative 2 is 2. 2 times 1/2 is 1. 1 plus 1 is 1. It is 2. Becomes 1 plus 1. So we're going to keep on going. Let's finish this guy out here. 1/2 times the absolute value of 2 minus 3. 2 minus 3 is negative 1 plus 1. So we get absolute value of negative 1 is 1. 1 times 1/2 is 1/2. 1/2 plus 1 is 1.5. Yes, dear. Yes, dear.
So for the
Mhm.
x value of 1,
Mm-hmm.
you multiply 1/2 times negative 2.
We have to do the absolute value first. So the absolute value of negative 2. It's how many steps away? Yes.
And then multiply.
And then multiply. So 2 times 1/2 gave us positive 1. So let's count these points and make sure we have enough that we need. Negative 2, 3.5. Negative 1, 3. 0, 2.5. 1, 2. 2, 1.5. Have we found the bottom of the V? Has it come back up? We got to keep going. So let's see if 3 gives us a bounce yet. In fact, I'm going to give us a little bit more space down here to write. So we're going to do our 1/2 times the absolute value. We have 3 minus 3. That's going to give us 0 plus 1. So the absolute value of 0 is 0. 0 times 1/2 is 0 plus 1. So we have a y value of 1. And it's still going down. Let's do another one. See if we can find the bottom of it. Let's try 4. There we go. 1/2 times the absolute value. 4 minus 3. Positive 1. So the absolute value of positive 1 is 1. 1 is 1 step away. 1/2 times 1 is 1/2 plus 1 still. 1.5. Whew. Finally, we found the bottom. It's going up there. Once we found that bounce point, we'll start to notice that they mirror each other. So if we were to plug in 5, we would get this point here that matches with this point here. Tomorrow we will start talking about it, and Thursday we will practice with it. A way to tell where the heck we need to start to figure out where the bottom is without having to do quite this many, because this is a lot. But right now, we're just kind of guessing around until we find the bottom of that line. I will show you how to figure out that point without having to do kind of a guess and check situation tomorrow into Thursday. Okay? There are 2 absolute value problems on homework 6. It's the same worksheet from yesterday. I believe it's 4 and 5 on the back are absolute values. You're just going to pick x's, simplify it, plot your points. Get me to the point where you have found the bottom of the V. Okay? I know yesterday we went really close to the end of time, so today we have a lot of work time. You can finish up that homework. Homework 6 is what you're working on. Okay?